When I graph a linear equation, like y equals 3x minus 1, that shows me all the points that there are where y is equal to 3x minus 1. When I have an inequality like y is less than or equal to 3x minus 1, that's going to include points that are not on the line, that are off the line on one side of the line or the other. There are infinitely many of those, so the way that we're going to show the solution to a linear inequality in two variables like these is by graphing, and then we'll shade the side of the line that includes the solutions. First thing I'm going to do, I'm just looking at that top inequality first. I'm going to graph that as if there were an equal sign in there. Y equals 3x minus 1. Well, that's a line. It's already in slope-intercept form. I can see my y-intercept is at 0, negative 1. That's about here. And my slope is positive 3. So from that point, I'm going to go positive 3 in the y direction, 1, 2, 3, and positive 1 in the x direction. There's that point. We'll connect the dots. I have y is less than or equal to 3x minus 1. So the points on the line are also part of the solution. So I'm going to graph a solid line. There's what it would look like if I had an equal sign and I'd be done. But I don't. I have less than or equal to. So I need to figure out which side of the line contains points where y is less than or equal to 3x minus 1. The way I'm going to do that, I'm going to pick a test point. You can use any point you want that isn't on the line. My favorite test point is 0, 0, just because it's usually pretty fast to figure out. So I'm going to try the point 0, 0 in that inequality. Well, y is 0. Then I have less than or equal to. 3 times 0 is 0. I need to write that really. Minus 1. 0 is less than or equal to negative 1. Well, no it isn't. 0 is more than negative 1. That's a false statement. So that tells me that 0, 0 is not a solution to this inequality, so I'm going to shade the side of the line where 0, 0 isn't. Here's 0, 0. I'm going to shade the other side of the line. That's down here where 0, 0 isn't. So every point on this side of that line is a solution to that top linear inequality. I'm going to do the same thing for the second one. I'm going to graph it first as if it were an equal sign in there. X minus 2y equals negative 2. That's not very convenient for graphing, so let's put it in slope-intercept form. First thing I'm going to do is subtract x on both sides, so now I have negative 2y is greater than x, negative x minus 2. And now I need to have y and not negative 2y, so I'm going to divide everything through by negative 2. If you think back to inequalities, when I divide an inequality by a negative value, it switches the direction of the inequality sign. So I'm going to have y instead of greater than, it's going to turn around to less than. Negative 1x divided by negative 2, that's positive 1/2 x. And negative 2 divided by negative 2 is positive 1. There's my inequality in slope-intercept form. Let's graph that first as if there were an equal sign. So my y-intercept is 0, 1. There it is. Slope is positive 1/2. So I'm going to go from that point, I'm going to go up 1 and 2 to the right. There's another point on my line. This time when I graph my line, I have y as less than, but not less than or equal to. So the points on the line are not part of the solution. To show that, I'm going to make my line dotted or dashed. It does not want to. So that That's what it'll look like when I don't have the or equal to, just strictly less than. So there's my line as if there were an equal sign in there, but it wasn't just a line, it's an inequality, which means I need to know which side of that line to shade. Well, I'm going to do the same thing. I'm going to pick a test point. 0, 0 is not on my line, so I'm going to use my favorite test point, 0, 0. And I'm going to substitute. It doesn't matter if you use the original form or the current. I'll just use the current one. That says 0 is less than 1. Oh, well, that's true. 0 is less than 1. This time I'm going to shade from my line toward my test point. Since 0, 0 is one of the solutions, there's 0, 0. I'm going to shade that side of my line. So every point down here below that red dotted line is a solution to that second inequality. For a system of inequalities, which is what we had here, our system of inequalities, we're going to want for the solution everything that we shaded for both of them. Which means the solution to my system of inequalities, if I look at them together, is everything that's shaded both red and blue. So that's everything to the right of this solid line, everything below this dotted line, everything in this area here. So the black part is the solution to the system. The red part is the solution to the second inequality. The blue part is the solution to the first. And the black part is the solution to the system of inequalities.